So I'll give you like perfect example. You guys seeing numbers, that's data. You getting signal or Wi-Fi, that's data, right? So any other forms of data you guys can give an example of? Like binary code in computers, video image, which is also binary code underneath the hood. Lots of data for you.
Chess moves represented as strings.
Correct.
Which you can get GPT-2 to play chess against you that way.
Sure. Cool. What else, guys? Like in your day-to-day interaction, what do you get data? You play games? Yes, that's data as well. Again, if you click your mouse, there's data being processed from that user interaction. So an example would be, where was that? Data. An example would be here. Like, I played a lot of League of Legends, and if you click something, again, when you click something, that's data, it will get processed, and that data goes to the server, and now the server would do whatever it wants to do to move your character, kill that, get that pentakill, whatever, and then go back and, again, update your character. So that's basically data being processed. So again, if you have your cellular phone, you get signal, someone calls you. Again, those are streams of data, binary data, again, through the wireless. Gets being sent over. Okay. There's a lot of form of data. So again, seeing a QR code, that's data, but again, you can't process that by your own. Okay, if you can process that, wow, you have bionic eye. So data as well, seeing the text, that's data, but once you process that to say CTU, right? It's a school, that's now information. Okay, so even seeing the signs, stop signs, when you see the red light, it's data to you, right? But most of the time for us, even for me, when I see the red pedestrian light, it's data, but I still walk. It should not, right? Okay, let's see. So again, data. There's a lot of data where we can get them. So there's scientific, cultural, geographic, transport, natural, meteorological, statistical, financial. So why? Why do we have data? There's a lot of data. Like even our human body, just getting the genes and storing that into information, it costs around 15 gigabytes to just store your human data, right? So the question is, why do we use data? So let's ask the question again. Why do you use data in your daily life?
To collect information.
Okay.
See the pattern.
See the pattern? Sure. Yes. Anyone else? How do you regularly use data, and what's the most useful data? Let's say given this in this category. Data?
Prediction. Prediction.
Google Maps.
Google Maps, definitely. Data that becomes information, and then now information, once you see it, you process that more, it becomes knowledge, and now becomes wisdom. We'll talk more about that. So there's a step of process. There's raw data, you process that, and usually we call it information. That's the one we consume daily. Because data is just data. You can't really do anything unless you process it. So now, because there's a lot of types of data, and then lots of industries now generate a lot of data because of sensors as well, because of IoT, Internet of Things, there's a lot of data being generated every day. Just in Facebook alone, I think they generate about 5 petabytes of data for the daily activity. Have anything to share?
You want to talk about data, some of the databases that back
Go ahead.
AWS or some of the databases that back AWS are on the order of billions of rows. Like just the Redshift database that we deal with is like gigabytes and gigabytes and gigabytes of just, and it's nothing. It's just account data. It's just like, you know, this person bought this thing on this day. Like it's just because of the scale of trying to do do things and keep track of all those transactions, and it just keeps generating. And so like Facebook is tracking like where you clicked, what you clicked on, what you looked at, and it has so many users that in their database it's probably the same thing. It's probably just like all, how many people clicked this video? Oh, this user clicked this video, this user clicked this video, so on and so forth until you have, a couple gigabytes of, a couple exabytes of nonsense.
So usually that's one of the big problems now. So we have data, lots of data, and now it becomes big data, right? And now, before, I guess last decade or last decade or so, it's hard to manage that large, big data because it's so expensive to store that somewhere. Because again, data is nothing if you don't store it anywhere, right? So you have to store it somewhere. So now you store it in let's say a server, which is there's a database in that server, right? And the problem now is it's too expensive. But right now it became super inexpensive, cheap, because Amazon came. There's Google, there's Microsoft. They all have this what they call cloud computing, which you definitely, it's basically you just have someone else's computer that you're using, you're renting. So instead of you buying your own computer, which is, you can call it a server as well, and store memory there, you can just say, hey, I'll connect to Amazon Web Services and use their computer/server and store the memory there. So that's one of the way we try to store this huge amount of data, right? Again, I guess most of you guys as well, even if you're not technical, you basically touch upon a lot of data when you're doing financial analysis and you're doing statistical, linear regression, getting that confidence interval, stuff like that, your two-sum regressions. So, and again, the more data that you have, the more that you can do good decisions. And now, your data can be used to do calculations, further calculations, make reasoning. Again, plan more. And then now it's shifting towards like human decision making. And then again, when we process this one, it becomes information, right? And now you have a bunch of data. This bunch of data, when you process it, either through a computer or a human brain, now it becomes information, which I talked many times already. And again, data for the computer side is just a lot of binary bits that gets processed, and again, it becomes information. And if you're wondering why binary bits as well, because anyone else knows the reason? For me, I think I only know because it's very cheap to store 1 and 0 states instead of, let's say, 1 to 100 and have different states as well. Because this one you can just do flip switching, on or off, on or off, on or off, something like that. So, anyone else knows about binary bits? Go ahead, share.
I think binary bits is used in security. I was reading the Security Plus book. It was like they use it to store personal information.
Mm-hmm.
I forgot the reason why, but it's like the best secure way to do it because it itself is encoded into alphabets now that decodes who you are and information about you. It's easier to store, faster to store too.
Mm-hmm. And again, for humans, it's not readable.
Unless you know
Yeah.
001 is like below or something or red.
Yeah, so thing is, now let's say you've learned bit manipulation, you understand bits, but now you have like tons of them. Now you need to know when the sequence stops so that you can get one sequence and translate that, right? We talked about this. We started about with data. Becomes information. So let's say raw data is red light, and it's also a, is this IP address or something, or maybe just a Google Map address. And then information becomes, let's say, south-facing traffic light on the corner of, let's say, Wall Street and 5th, right? And then has turned red. Now, you have the knowledge that when it's red, you should stop. But again, with wisdom, you can either use it to your advantage or do other stuff. Again, with wisdom, you just stop at the street. But sometimes with wisdom as well, you know there's no one there, you just cross the street. So that's something to take note about wisdom as well. So now, before even mentioning this, so enterprise, right? Enterprise is basically business, organization. We all know that an enterprise would have the finance department, the human resources department, the sales department, the IT department. It could be smaller, could be larger, and again, an enterprise basically has a goal. Could be either for making money, for profit, non-profit, like this school. Could be for charity as well, right? Which is, again, sorry, it's non-profit as well. So how do enterprises survive, right? So enterprises survive by also getting data, but not only any data, it should be a data that it's useful. Now the question is, how do you find data useful? How do you know in your experience? So someone over there can say, how do you find data useful or not for decision making? Oh, I can't hear you.
We can get a new knowledge from data.
Okay.
New information. So data is useful.
How would you know if it's useful or not?
Through the data which we can get new information.
So I guess the data, again, would now still depends on your relevance. And let's say you're the user, what's relevant to you? Let's say you're studying this class. This is relevant to you. IS 306, the textbooks, is relevant to you. But let's say I give you another textbook, which is, let's say, your data. Do you think it's relevant to you? No, as well. So think of it like that. Let's say you're also flying an airplane, and then you see a pedestrian line. Do you still follow that? No, right? So it's not useful to you. So going back, now you're in the business as well. So depending on what your use case is, your goal, trying to make profit as well, there are certain data that are useful and not useful to you. So let's say you're an e-commerce website selling, let's say, shoes. Do you think hand size is important to you? No. So things like that to think about. Go ahead.
One more thing to add.
Go ahead.
When you decide to store or not store certain data, why you are storing it or not storing it is relatively important, because otherwise you wind up wasting resources or introducing noise into your analysis that you don't need. So selecting the reasoning behind what data you're collecting is
Again, to add to that, again, he mentioned about resources. Businesses has limited resources, except for Bezos. No kidding. Businesses has limited resources. That's why we have to take into account what data we store, because we have to store them, right? And then now, what he was saying as well, that it could add a noise to your data. What it means that, if let's say you're a business intelligence analyst and you're plotting data points, and now you're extracting data, and now you have that hand size as well. Do you think you would have a good representation of data if you accidentally included that hand size data for your shoe wear? No. Okay? And I guess it's in the slide. Reduce wasted money and time. Data storage is very much important, as it protects and retrieves your data whenever you need it. Since data can be now stored in the cloud, security also increases. Security feature increases. So have you ever encountered your friends, family friends, or small business storing their data in Microsoft Excel? Have you guys heard of that? Do you think it's a good way to use or not?
depends on your data set.
Sufficient.
Correct. I would say both correct. So if you're really, really small and you wouldn't reach, let's say, 1 million rows, it should be fine. But then again, there's a lot of things that you have to consider as well, because there's this topic like, why not just put Microsoft Access, which is kind of acts like a database as well, right? Well, a lot of people already knows Microsoft Excel. It's like saying, I know English, I would learn Mandarin, but I don't need to use Mandarin, so why learn it for, business, right? So it's kind of like that. So again, data storage is very important, because again, in Excel, again, you can store, but the problem is sometimes when you destroy your data, it's harder to retrieve it. But again, now Excel has version control, so we can argue with that as well. But then again, if you have someone with the skills like an Excel expert, he can do a lot of charts, which is good, and a lot of business intelligence analysis as well, which is good. Okay, so going back to data storage, so we have to store the data so that you can retrieve it later on. Because again, if you just consume the data, that's it. You may forget it as a human, and as the computer, if you did not store it in the physical memory, which is you store it in the RAM, random access memory, which is temporary, it just goes away when you shut down your computer. So now you have to, again, make sure you store it somewhere, and also, it's also more secure to do that anyway, instead of just putting it anywhere, text file, whatever. So we talked about a while ago about binary bits, right? And we consider those types of data as digital data, because again, you don't get to physically touch them. They're all in the cyberspace or computer space, okay? And if you still remember how to compute, I still forget this from time to time, that this is how you get a binary bit and convert it into a decimal, which is the regular numbers we're using. So every bit, you just raise it to the power of 0 and then increase by n, meaning +1, +1, +1 until the end of your binary bit. And you always see this in movies, interestingly, Matrix. So this I just sidetrack a bit because we do have a paper about data sensors. So just to give you an idea, there's tons of sensors that you can talk about in your research. So because there's temperature sensors, proximity sensors, pressure sensors, chemical sensors, smoke sensors, motion detection, and what other sensors that we have from day to day? How about you? Any sensors that you have on your hand?
Like a light.
Light sensor? From where?
It's like a voice sensor.
Yes. So like the voice recognition, like I guess Siri for MacBook, like, and then Cortana for Microsoft, and then what's the other one? Alexa.
They're not really sensors though. They're a sensor and a thing.
Correct.
Built on the sensor.
Correct. So again, there's a lot of ways to get data, as well as your Apple Watch or whatever your device you use that makes the government track you. No kidding. So your location again, things like that. Smoke sensor, fire. You can detect smoke. Temperature for room, also for your body if you're getting a fever.
Sorry, I have a meeting. I'll be back.
Yeah, sure. Go ahead. So for data sensors again, let's say we have your sensor detecting getting a data, and then that data is just sent over the wireless. Let's say you have your wireless device that can turn off your home light or automatically. So basically when you move past it and it senses there's an object, and now once it senses that one, let's say you have an IoT type of home lighting, now sends that to the wireless and now acts upon it, and let's say maybe turn down the light, turn up the light, process that into more data. So another way for data sensors, so let's say you're in a warehouse, we can have something like that. Let's say this box, is it according to the specifications that you put for this computer? And it would say pass or fail. Let's say you can use that for quality control as well. Okay, so aside from that, we'll discuss what are the tools that we're going to use in the hands-on. Just because I did not put a lot of information there, because I want you guys to research as well. Because everything you can Google, and turns out, again, especially true for software developers, is the more keywords that you know how to Google, the better you are as let's say a developer as well. Because if you don't know how to Google stuff and you end up bugging the other person many times, that's also a waste of resource for companies, right? So knowing how to Google, thing is, what you have to learn is you have to learn what the keyword is. If you saw a website, you saw what's this bar? You don't even know what it is. But if you know it's a navigation bar, you now can Google navigation bar, and then you can find your answers right away. But if you don't know the context, it's gonna be harder. Go ahead.
Should we do this individual or could we help each other if I know how to do it?
Right. So for the hands-on practice, I would mix people up, and then those who have, let's say, more advanced knowledge on this, definitely please help the other person. It's learning by teaching, and then definitely you have to be aware what the other person is coming from. We call this the proximal zone of development. There's 3 stages. Things that I can do, things that I can do with help, things I cannot do. What is an example of this? Let's say I teach someone with programming. I teach someone with, let's say, for loop. And I teach him right away about web development. He's gonna get freaking lost. So that's why you have first to be on the middle and teach, let's say, object-oriented programming or about system design. And then now once he closes that gap to the second stage and now becomes that first stage, now you can teach him about web development or web design. Okay? So that's how you practice, how you communicate in the workplace as well. Don't go about, oh, you do this, you do that, and then, oh, why you don't understand. So that's why it's also kind of a bad practice to, let's say you have a senior developer and you match that to the intern right away. No, they would have a big gap on the knowledge. So you would rather have, let's say, a junior developer and make him mentor the intern. Okay, something to think about. Okay, moving on. So we'll talk about Docker. So in the technical sense, Docker is a set of platform as a service products that use operating system level virtualization to deliver software in packages called containers. First, we'll talk about platform as a service. So there's 3 types of service and then tons of other different services, right? We have software as a service, platform as a service, infrastructure as a service. So first, let's talk about software as a service. Can you guys give an example? Software as a service?
No, not really.
So,
Kindle?
yeah, Kindle Reader, the app. So I'll make it very simple. Software as a service, you guys interact with it all the time. So yes, Amazon. But again, if you have the application, yes. So for example, Outlook 365, that is software as a service, right? You don't really need to build on top of it to create an app. You consume the app. So Microsoft Excel, Google Drive, all of those are what we call software as a service. That's the general category, and then a lot of people try to do subcategories. They can say, oh, this is called storage as a service. Oh, this is called email as a service, which all falls under as software as a service. Now that you guys know that every app that you interact that you don't really need to build on top of it, it's called software as a service. You can customize it, sure, but everything is from the developer or the organization who business who, again, sells that to you. Now let's talk about infrastructure as a service first, because this is on the middle. Infrastructure as a service, an example that I talked about earlier already is, let's say you have, you don't want to use your own computer to do something to build your app, right? Let's say you want another computer. So now you go to AWS, let's say you use Amazon EC2 instance, which is Elastic Cloud Compute, and now you can use their own computer, just basically log in like remote desktop connection, and then now use their computer. So they give you the infrastructure. And again, now you have to still manage that computer, upgrade that to avoid virus, bugs, fix that. You have to fix that by yourself. So again, infrastructure as a service, you just poof, okay, you can use my computer, just go connect. Platform as a service, on the other hand, is something like you get it with the infrastructure, plus now you have a platform that you can do stuff. So A perfect way to give an example here is, let's say you're in the restaurant. If you're just buying food and getting to consume it, you're definitely doing software as a service. But let's say you go into a restaurant and say, here's the kitchen, cook for yourself, right? So that's kind of like going to the infrastructure and platform as a service. So again, this is kind of in the middle ground, so please, you might get confused, but that's fine. You would learn more about it as you go research more, and then we'll talk about the operating system level virtualization to deliver software. I think it's the next image. Okay, so Docker is this cute whale logo with containers. Okay, so basically infrastructure. Think of this. This is your computer. This is your infrastructure. Host OS could be Mac OS, Windows OS, or Linux. And what Docker is doing is basically putting this layer and putting this container. In a small nutshell, why are we using this? One is because for developers, let's talk about developers first. For them to work on, let's say, an app, let's say I hired you as a developer, and let's say work on the Amazon e-commerce site. It might take him weeks or 2 weeks just to give him the right dependencies, installation, to use SQL, to use this technology, to use Node.js, to use whatever, even different version. So now that's a very, very hard problem to solve for the development environment. So what Docker is doing is basically giving you, hey, there's this app, it just runs. So a very, very good analogy for that is, let's say you're doing Windows. You install something, and especially if you're gonna code, you're gonna fix the path, fix the whatever binary, installation path. Unlike in Mac OS, you just get the application, drag it to the applications folder, it just works. So that's a close analogy. If you at least one takeaway from that, get the app, it just works. And again, an example is you have the Docker and it's sitting on top of different, you have different containers sitting on your kernel. Okay? Kernel is basically the one that interacts, it's like your middle layer. Kernel is interacting both for the software and hardware. So meaning if someone attacked your kernel, it's goodbye. Okay? Attack meaning someone messes around, cyber attack, hack you. If someone touched the kernel of your computer, you're goodbye. So again, containers just sit on top of that, so it just works. And why should we even learn Docker? Thing is, everyone uses Docker nowadays to ease up the development. And you as a business person as well, you have to know what are the tech people using. Because you have to next time know, okay, Docker, okay, costing, okay, resources. Now you have to do the pricing. Is it worth so much? Is it really giving you productivity? So a lot of things to consider for the business as well. So before containers, we do have what we call virtualization. And this is a virtualization. Basically, you have your computer, called server, and operating system, Mac OS or Windows OS, and then now you have to have the hypervisor application. And now you would also need to put another guest OS, meaning I need to have another Windows OS inside of my Windows OS, or a Mac OS in my Windows OS, or a Linux OS in my Windows OS. So now you have two operating systems in one stack. Very inefficient. So with your Docker, you just have this one and the Docker engine, and you have your applications on top of it. Okay? And what's good with that is when you hit Docker run whatever command, it will just run the scripts for the dependencies, and then it's good to go. So we'll touch upon MySQL as well. For business people is you need data storage. want to do business intelligence, you have to know R, Python, Tableau, what's the other one? Power BI, and SQL as well. Because again, depending on your business, you might have MS Access as well, which is also a database. So one of it is, I mean, before going to that, I do have a lot of friends who are into the business analyst position, and most of them do study up SQL. So they would know more SQL than me, just because they need it day to day. So with SQL, it's just what you call a structured query language. It's not a programming language, it's a query language, meaning you ask something to it, and now it returns something to you. So in structured query language, we do have a lot of different database management systems. So think of it, this is just, SQL is just your general word, and now you have the proper nouns, which is MySQL, PostgreSQL, and then many SQL, whatever SQL. So again, MySQL is one of those database management systems where you can store data and interact with it. So MySQL is basically an open source relational database management system. Relational databases means it's a type of database when you have tables. A table is basically an entity, an object, meaning I could say it's a person table, and that table, person, can have attributes. What attributes? It could also have an address, first name, last name, things like that. Okay? So aside from that, let's say you have a table called courses. Let's say IS306. And now you have the student ID number inside of it. And now you make a relationship with it. And that's why with this type of database, which is a SQL database, you can draw upon many tables and you can create relationships for them. This is opposed to what's getting more popular nowadays is NoSQL. Basically, NoSQL uses JSON object, JavaScript object notation, which is called JSON. So if you know JavaScript, it's basically a JavaScript object, meaning an object is something that you can store data as well. So in the JSON object, you just fill up the data, key pair, and then you index, you query. It's a much more complicated way, especially every one of us learned a structured way of querying, which is the SQL one. So a lot of people who come from a SQL background might find it hard to do NoSQL as well. And again, even though NoSQL is popular, like MongoDB, like AWS also has this, what is called, I forgot. Yeah, there's a very popular NoSQL database. You remember?
NoSQL?
Yeah. DynamoDB. I remember. So DynamoDB is another non-relational database management system. Super popular, but again, people think in the business level, oh, it's popular, use it right away. No. So there's still a good use case for doing SQL. It's not, again, there's a lot of pros and cons. Again, it's structured, it's known in the industry, it's easier to use. So a quick overview, you don't have to remember this, but just a quick overview. How does the MySQL architecture looks like? It basically, you interact with the application layer. It could be a GUI. GUI means graphical user interface. It's the one that you open an app and there you can click and do stuff. Or you can do the console to interact with the application layer. Console meaning in your Mac OS, if you open up terminal, that's a console. In Windows, if you open up command prompt or PowerShell, that's also a console. You don't have the graphical user interface. And then you would now ask, okay, as a regular user, a lot of us use the graphical user interface to click around and do stuff. But once you go to the development side, it takes a lot of productivity and time away from the developer to click stuff instead of just typing stuff and getting things done. Hey. Okay. I won't talk about this stuff, but only this one. So for those who are doing development and then did the IS375 or 131, you basically got, I think you got the experience of using a programming language to connect to your MySQL server or whatever database management system, and you need to handle the connection pool, which allows you to connect your code code base to connect to the database and do your queries there. Okay. So now we have Docker and MySQL. So Docker, again, looks like this. This is the host. This is Docker. And now when you do the hands-on practice, your MySQL sits on top of Docker. That's just what I want you guys to take away from this image. And then now it would just expose this 3306 or whatever port you choose so that you can, again, open that port and use that MySQL instance. So let's talk about muddiest point. So try to summarize some of the people that I've asked. So some person asked about data inconsistency. So how do we solve from them? So when you're using Excel, basically there's a lot of human error, duplicate data, and the only way you can do it is maybe click filter, replace, find, or maybe just have another person pass it to the other person, check if there's duplicate data, and then check if it's everything all right. But now if you're dealing with databases, especially relational databases, you can solve this data inconsistency by putting primary keys, secondary keys, indexing table, normalize table. Don't worry about a lot of these definitions. I'll talk more about this for the coming weeks, but I can quickly say stuff like primary keys is basically an attribute of your table, let's say person, to signify its uniqueness. So meaning, what if I store my information as Clark, NGO? There's bound to have another Clark, NGO as well, right? So we put a number that's unique. I could be number 1, he could be number 2, and that makes it unique. Secondary keys, more advanced. Basically, you put another table's primary key in your table. We'll talk more about that, so skip that first. Indexing table is basically when you index your table, you can do more fast queries. Normalized table is just a set of standards and best practice so that you avoid duplicate data and stuff like that. Someone asked about data centralization, and for big data, yes, it does have advantages, especially for businesses. So think of it like this. When, let's say, Walmart, Walgreens, or whatever store is still very small, right? So when they were building up their business, they would have a sales team. And now, let's say you bought an app for that person, software as a service, Salesforce. You also bought them email as a service, it's called MailChimp. And now you have an HR person. And let's say that HR person needs an app called PeopleSoft to manage people. Things like that. Or now you have business analysts using, let's say, SQL database, things like that. Now you have different applications, right? So that's basically them being siloed first, and then you would want to connect them together to interact. Why? For example, I go to a retail store, I buy that, what's that? I buy that bar. And then, let's say it's an e-commerce. Let's change the situation. It's an e-commerce site. I click buy in Amazon for that bar. If the data is not centralized, meaning, let's say the data is inconsistent and it's not updating correctly, I see one, I click one, I buy one, but turns out in the warehouse, they don't have any more. So that's a big problem. But if you have centralized data, now the inventory would update that, hey, front-facing web page, hey, Amazon e-commerce web page, please update your data that it's now 0. Okay, because again, it would cause a lot of overbooking. I don't know why they still do that in airplanes, overbooking, right? So again, advantages, and for again a lot of business people, you would encounter technologies as CRM, Customer Relationship Manager, SCM, Sales, I forgot, sorry, it's not often, ERP, Enterprise Resource Planning. An example of those, which is very popular, is SAP. If you heard about SAP or SAP, basically it tries to integrate everything to be SAP application. Going back to the example, going back to Walgreens, let's say they have different applications, right? Now they're super big. They're Walgreens USA, Walgreens worldwide. Now they would have the problem of having different types of applications interacting with one another. So now they would go to a consultant and let's say have them apply this SAP system so that everything is consistent. Everything is SAP application. So that where you get in another, that's another track that you can go both as a technology and a business person. Go to SAP type of work, Enterprise Resource Planning. Okay, it also provides in-depth insights for BI. We'll go back to, let's say the hand size, foot size, again. If it's not consistent, then you would have bad BI, business intelligence. And also with the warehouse and the front end facing website not updating correctly, that's also gonna produce wrong insights for business intelligence. Business intelligence, again, that's where you do charts, do dashboards, so that your manager or your CEO can just look, okay, I know what's wrong, I know yes or no, instead of trying to look around all the data and wasting his time. Okay, and it's cost effective. Matthias point, SQL to NoSQL migration, more technical, but the steps are basically, if you have a structured database, you would have access to entity relationship diagram, meaning the tables that you see as a picture. When you have that, make sure everything is normalized in standard so you don't have data inconsistency. And now you would try to extract them using SQL joins. Why do we need to do that? So that we try to format them in such a way that it kind of reflects what we want to put inside a NoSQL type of database. And then basically you need to produce code for data migration. So a lot of consultancy firms are being paid a lot to do migrations, either application migration, like let's say from Outlook 365 to Salesforce, things like that, or even SQL to NoSQL. So defining if the data is needed or not, very, very good question. That's the first thing you have to ask. Is this relevant? If it's not relevant, please don't take it unless you do get a lot of data and you can store it and now you can sell it to other people, which is tricky, right? So like Facebook, it grabs all the data, sells them to whoever can use that. As for business intelligence, as for maybe propaganda, things like that. So, and then that's why if you don't know, collect it anyways. Because you might, if you don't still know what you need, just collect it for now. Why people use Excel, I talked about it. Everyone knows, it still works, easy to share, small learning curve, and then people against on change. So again, this now deals on the topic of when we're migrating to a new system, now you have to have managers who are good with change management, and change management requires you to be influential, aside from that, and also getting a champion from, let's say, your team of analysts, developers, data encoders. Find someone who shares the same vision as you and make sure that he can try to influence the team as well to move to the new change. This is quickly explaining the hands-on. Oh, almost done. On the next hour, we'll do hands-on. I'll quickly explain the first command. So again, usually you install a lot of stuff, click, change path, change whatever. For Docker, after you install Docker, you just hit Docker run. It means run the instance. Instance meaning a thing, run the instance. We put it as a name as MySQL instance, P is basically what port are we gonna use. Computers has ports that you can expose. Once you expose a port, that now acts like a server. Okay? So expose this 2 ports. And dash E is basically environment variables. So this is such a pain when you're doing development as well, because like you need to store your secret keys to be able to, you need to use secret keys first to be able to use AWS, Azure, MySQL, stuff like that. And then usually it's a hard time setting it up, like even for Java. You have Java, you need to put that in the correct path, correct directory, those environment variables. But in this time around, because it's also authentication, also have to put the password, which is, in this case, this is the MySQL root password, and this is the password you want to put into. I know it's unsecured, but no one's gonna go into your computer anyway, and it's easier to remember this type of password because I installed MySQL, lost it many times. It's so freaking hard to retrieve your passwords for your MySQL. And I've done a lot of safe mode, go to this, whatever. It's hard once you lose the password. But that's why try to use this simple password for now and not forget it. Again, I know it's unsecured, but you're not really exposing it to the internet, so you should be fine. Okay? And D is just means detached. It means it will still run in the background. So if you open this up, it will run in the background. What runs in the background? Example, when you open Skype, you click exit, it still runs in the background, stuff like that. MySQL :5 just means I want to use MySQL version 5. That's it. And let's take questions first. Go ahead.
I can't seem to down the Docker because it's just
Windows
Windows Home.
only.
Like it's because it says you have to have Windows Pro or Enterprise.
Yeah, so I found out that due to Robert,
What?
one of the classmates. I don't know, anyone Robert here? No? Okay, he's not here. So he's the one who suggested that. And basically I posted in the question and answer discussion board the workaround to have the Docker. I know it has more steps, but it's basically a learning environment. And as long as you tried it, did not work, show me the result. Let's go to the next plan B. Just go get a MySQL instance.
Okay.
Yeah, but hopefully for most of you guys, have installed it, and we're gonna do pair programming in the next hour anyways, and I'll also try to help you out. So I'll be uploading this updated slides as well. Let's take a 10-minute break again, and let's continue on with the next session. Thank you.
So the next session is programming, setting up SQL Server.
Correct.
That's the plan. Okay.
Yep. We need to help people out.